So I'm going to talk about this concept of building precision tools for the imagination with AI. I'm Nikhil. I work here in a group called Opera of the Future. Often we build technologies for large-scale performance experiences like concerts. So question I want to ask you is, think about at a high level, how do you experience a concert? When you go to a concert, it looks something like this maybe. You have this experience through your perception, and you can remember it later. You can think about it, and these memories can have deep personal and cultural significance. And in the modern world, you can also record these experiences, store them and retrieve them, and really kind of experience them again at a later time. And this is really powerful because now these recordings can have deep personal and cultural significance. So at a high level, these recording technologies expand our ability to have these sort of memories by turning our experiences into artifacts. And we've built an incredibly rich stack of tools and really industries around this in order to be able to author the most incredibly immersive and expressive experiences as artifacts. Now, recently, we've seen a new class of tools, generative AI models, and these do something a little bit different. They can generate text and images. They can turn our ideas directly into artifacts. And this is really powerful, but it also leaves us asking, what does this mean for human creativity? It kind of brings this automation, augmentation tension back to light. And we've seen bestsellers repeatedly make the case for human augmentation, but how do we actually do this when the models are doing some of what we used to do? The core question behind a lot of my research is how do we actually design computational tools that augment human creativity? And the core thesis of my work is that we need precision tools for human AI co-creation. What do I mean by precision tools? Let's take an example of sound design, which is a domain that I've worked in personally extensively, and you've experienced through things like film, some of your favorite electronic music, through advertising. So sound design has just started to be affected by AI. We can do things now like think of a sound like bird tweeting and pass this into a model like AudioGen or Audio LDM recently and get sounds like this. Here's a bird tweeting according to AI. And here's a bird tweeting according to a different AI. Chirp, chirp. OK, so we've got those birds tweeting. And the way that they do this is they train on real recordings of birds tweeting. And they sound a little bit like low-quality recordings of birds tweeting. That's very different than often what we want in sound design, which is a kind of abstraction. What we want is to make you imagine the sound that you want and make it seem real. For example, bubbles don't actually make sound, but often in film and television and animation, bubbles have sounds because sound designers kind of tap into your imagination and can build these sounds and make them feel real. In this clip, which I won't actually play because you won't be able to hear it, Academy Award-winning sound designer Mark Mangini from Dune, Mad Max Fury Road, many other things, talks about this idea of abstraction, comparing it to how Picasso constructed images from squares and basic shapes. The idea being that you can create these sounds by putting other things together and evoking the sense of what they should sound like. And how do sound designers actually do this? What kinds of tools do we use to do this? One toolkit that we've used for many decades is called a modular synthesizer. Really, a modular synthesizer, you can think of it as a graph of components that you connect together, and you can tweak them to make a wide variety of different sounds with really precise control over the outcome. So, in this clip, Herbie Hancock and Quincy Jones, two legendary musicians, talk about synthesizers. There's some subtitles so you can actually read that they say that synthesizers were designed for people to use, and really emphasizing that it's for people. And like an axe can be a tool to cut wood, build a house, or, as he says, a tool to slaughter your neighbor. But this provocative statement is really kind of talking about the synthesizer as a tool to create painful, dull sounds, or to create really beautiful, expressive sounds, as both Quincy and Herbie have done for most of their careers. And it really depends on the person that's using it. The thing that they really emphasize is that it's not really the machine's fault in the case of the synthesizer, because synthesizers don't really program themselves. We have to program them. We have to create with them. And that can take a lot. So in our work, 40 years later, we're actually programming synthesizers themselves. We've built this project called CTAG, and I'm going to have to tweet for you a little more because we generate bird sounds with this that are dramatically different from the kinds of recording-like bird sounds that are created there. And they sound a little more like, I think one of them is almost exactly like that. So these really abstract birds, they sound more musical, they sound more kind of creative, and it's not just that. You can tweak them, you can play with them and make them your own. And the way that we do this is by emulating the sort of human approach of synthesizer programming, where you listen and then you tweak this incredibly large number of knobs and parameters to be able to create the sound that you want. But what we do, in brief, is we turn this into an optimization problem where we try to align the sound that you want expressed through text with the sound that we can generate by tweaking the parameters of the synthesizer. At a high level, the reason we call this a precision tool is that it has these capabilities of a modular synthesizer in that it's tweakable, it's interpretable, and it's playable. So it has all of these qualities that sound designers and musicians crave. But it also has the powerful capabilities of modern generative models in that you can guide this with text. These generate much higher quality sounds than traditional neural audio synthesizers. And it's much faster as well. You can generate these sounds in real time really quickly. We can also interpolate between sounds. I won't try to vocalize this, but we can go from things like a bird to a chainsaw to a helicopter with really fine-grained control at every step in between and really explore the space of possible sounds. This is a really powerful thing that we couldn't really do before because it's really hard to derive any one of these, let alone try to smoothly morph between them. So this opens up a lot of possibilities for sound designers in ways that both they can precisely control and we can program automatically using this AI tool that we built called CTAG. When people listen to these sounds, they can recognize what they are while still feeling like they're more abstract, feeling a lack of confidence in what they actually are, and seeing them as more artistically interpretive than any other generative models on the market right now. The key thing here is that people can tweak these knobs, people can work with them, and as Herbie said, they're designed for people to use, but also now machines can operate on them, and it's a shared representation of what a sound can be that both machines and humans can collaborate on to create the ideal outcome. At a higher level, I think this work really points to what we need for this goal of building precision tools for the imagination. We need better computational models. We need better interactive systems. But we also need to think really carefully about what optimal integration between these things look like and how we can design for that integration by creating these representations that both humans and machines can work with, such as a modular synthesizer. Thanks, folks.
Thank you. Yes. Do you want to explain to everyone what UDO is?
Sure.
And give a 30-second hot take.
Yeah, great. So hot take, Udio, Suno, we've seen a lot of amazing advances in music generation. And the way that they model music is often you type in a prompt and you get a piece of music. It's exciting that we can do that, amazing that we can do that, amazing we can do all of these things. But they're not really precision tools, right? What happens if you want to iterate on it? What happens if you want to have an idea? You want to have a bit of a voice and how the specifics go? If you want to add a layer, all of these things require tools that add a layer of sophistication beyond that. And those are the tools that have enabled the creative industries to thrive with recorded media artifacts. So my hot take, I guess, is that we need more and we should expect more.